just differentiate. It's not, there's no right way to.
Because you're like me.
One, 2, or 3 more minutes.
It's a voice.
Okay, you got one.
Still not on the wall. My desk was Fridays.
Three to the left, three to the right,
All of our
four up, three to the left, four down.
Are we using the original?
Always use the original. Check your partner, make sure they're correct.
Hey, partner.
Okay, ready? Negative 1, go across it. Negative 1, 2, 3, 4, 6, 1, 2, 3, 4,
Doesn't say it just says
Thank you.
You know what I mean?
I attempted to add the fourth one just to make it go with the
Remember everything's
I mean, I got 3
I think 1 and 2 are the same. Yeah, because I was
No.
well, 1 is
So-
to the left, and the up. Oh, that makes sense. So I'm gonna predict, based on what I know, that the relationship is gonna be x minus 3 and y minus 4
And so then here you
for any polynomial.
and then you gotta do two.
Who?
So me or her?
You.
And then
I am.
I see that.
Got 0, 0, 0.
I don't understand between you and.
so I'm gonna ask you to agree to.
No,
It's just for
Here's your
my 2, 1, negative 1,
It just come up with random variables. I mean, that's what I thought.
I have plus 0,
That's not a resource.
It's only plagiarism if you don't have permission, you have permission to use the words.
And I'll find her.
No plagiarism there.
Oh, wait, I know.
Technically, you don't even have to slide it.
Alright, try and walk down.
Right? That's what we're able to do. There's all sorts of wonky. No, but you meant. Yes, it's boxing. I know. What? I'll have your own box.
Okay, so we can come back together. Pam, you're not counting for me.
5, 4, 3, 2, and 1. Thank you.
So on number 1, this was the original triangle. And we had to translate it 3 units to the left, 4 units up. So I'm so glad Russell isn't in here because he would be arguing with the word up. So if the original coordinates were x, y, the new coordinates are, what is the abscissa for the new coordinates for number 1?
X minus 3, y plus 4.
Okay, x minus 3, y minus 3,
No, x minus 3, y plus 4.
y minus 3 for x,
No. What?
w-h-y
Y.
minus 3.
Why is 4?
Who's on first?
I thought you were doing that like, reverse psychology thing, trying to trick us.
So w-h-y,
Because 3 units to the left would be negative, so
Okay.
r to the
so x minus 3, and y, the letter y, what is the rest of it here?
Plus 4.
Plus 4, and why is it plus 4? I love that. I asked a question, I didn't call on anybody, and y'all are so used to me not allowing choral response that you're like, and then some of you tried to answer. So I probably should pull a stick out. So, Brandon. Okay, good. Still on number 1. What is the y coordinate here? What's the expression? I'm so glad, yeah. Here are the instructions. What are we doing to the y coordinate?
I'll take it 4 units though.
Okay, so what would I write here for y?
Y plus 4.
Y plus 4. Good job. So number 2, what would be the abscissa, the x coordinate here for number 2? Wait a minute. I forget. Alyssa.
It's going to be Melissa or Melissa?
Alyssa.
Okay, hold on, 'cause right now you said Melissa, I thought you were calling me. It's gonna be x minus 3, y minus 4.
Okay, x minus 3, y minus 4. And WHY is it y minus 4?
Because a downward movement is considered a negative movement.
Good. And why is it x minus 3?
Because the movement to the left is considered a negative movement.
Good. And y'all all had your teacher knowledge and you all knew that. Kids don't realize that.
I like the way she stated that though.
Okay.
A left, or say it again?
Downward.
Downward,
Alyssa, she likes the way you said it. Say it again.
For which one?
either one, just the way you worded it.
A downward movement is considered a negative movement, and a movement to the left is considered a negative movement.
Well said. Okay. All right. So, where my clicker is, so I'll just do it. So, I think we're going to skip this and go to the Pythagorean, because I think y'all pretty much got that, don't you? Okay. So now we're going to talk about the Pythagorean theorem. And again, this is a review, not of something I've done with you, but because I know you already know it, and because I know it's on your test. So we're just reviewing this, okay? It's like the star. You know, we're reviewing for the star. Teacher to the test. So I need my clicker. I don't know where I'll put it. Right here. Oh wait, Denise has it. Okay, the Pythagorean theorem.
Yeah, you use your finger.
So tell me, Rossius, tell me, Pam, what the Pythagorean theorem is.
The Pythagorean theorem is a squared plus b squared equals c squared.
That's the formula for it. What is it?
The Pythagorean theorem is a theorem used to find the length of a hypotenuse given two leg lengths. Or find a leg length given a leg and a hypotenuse.
What's a hypotenuse?
The hypotenuse is always diagonally across from the right angle of a right triangle.
Oh, okay. Yes, Brandon?
It's the longest side of
He didn't say that.
right triangle.
He says it's the longest side. Is that right?
I wasn't finished. Cut me off and
Is that right?
Yes.
Pam?
Yes,
Is
ma'am.
that right?
Yes, it is.
Okay, so the hypotenuse is always the longest side of a right triangle, but the best way to find it is opposite the right angle. So,
I wouldn't move forward.
oh, thank you. I must have hit it already. So the formula for the Pythagorean theorem is a squared plus b squared equals c squared. A and b represent the two legs, and c represents the hypotenuse. Yes,
And the
ma'am.
Pythagorean theorem is only used with right triangles, because my students think you can use it with all triangles,
Oh, no.
and they forget that it's only right triangles.
It's a right triangle theorem, okay? So why is it called the Pythagorean theorem? Brenda? I don't care about the theorem part. Where's Pythagorean? It's a funny name. Where did it come from?
Pythagoras.
Pythagoras. That is a man's name. So why is it named after Pythagoras?
Quentin likes to name things after
Quentin?
Well, we assume that he was the first, but it's attributed to Pythagoras.
He has the first written proof that we have found. So about what time frame was Pythagoras? He's Greek. So about what time frame?
He was a philosopher and a mathematician. He was eight.
I could put my Donald Duck movie on.
Okay, y'all are guessing. So raise your hand if you know about a time frame. Okay? Not 80 because he's Greek. He's a BC guy. So he's BC. So where is this? The Greek Empire was before the Roman Empire. The Roman Empire was in control when BC became AD. That period right there. More than just a day, but that long period. So the Greeks were before them. Okay, where were the Babylonians in that timeline? Were they before the Greeks or after the Greeks? They were before the Greeks, right? Well, they have found tablets, they call them Babylonian triples. They have found tablets of values that work with these right triangles, and they're called Babylonian triples. So we know that the Babylonians knew about the Pythagorean theorem before Mr. Pythagoras actually has a written proof of it. Okay? So maybe people before that even knew of it, but we know the Babylonians did, and Pythagoras has a proof scrolled in one of his books. All those books from Euclid and Pythagoras. Anyway, so a leg squared plus a leg squared is equal to the hypotenuse squared. When I first started teaching this, I had wooden Cuisenaire rods, and I had balance beams, double pan balance beams, not triple beam, but double pan. And if you take those Cuisenaire rods and you make a square out of the length of this leg, and you make a square with the length of this leg, and you put them in one pan, and then you make a square with the length of the hypotenuse, they balanced. That was with the wooden ones. With the plastic ones, you have to be a little more careful because they're hollow for one thing, and they have that little nub on it so they can stick together. So I haven't tried it with the new ones, but the wooden ones, if you hunt around and find some wooden ones, you can show that to your kids. It's really effective. They understand it then. Okay. So here's an example of the Pythagorean theorem on the coordinate plane. We want to find the length of segment JT. We want to find the length of segment JT. Another way to say that is we want to find the distance from J to T. So the length and the distance are the same. Now for you science people, this is displacement. Okay? But in math, it's distance. So don't let those words confuse you, and don't let those words confuse your students. In mathematics, distance is a straight length. And that's science's displacement. I hope I said that right. Did I say it correctly? Good. All right. So to use the Pythagorean theorem in the coordinate plane, we need to have a right triangle, don't we? Can we create a right triangle? Certainly can. We can create it like that, or we can create it like that. And it doesn't matter which one you use, because we're talking about a length, a distance, and distance is not positive or negative, it's just distance, okay? Because it doesn't matter which direction you're going. I don't say that I drove 280 miles from Lee City to San Marcos, but when I go home, I'm going to drive negative 280 miles. You just don't say that, even though I change directions, right? Now, I could go through the whole absolute value thing with you, but I'm not going to. I'm just not going that way. All right, so we need to make a right triangle one way or the other. So find the length of each leg of the right triangle. Let's do the vertical one first. What's the length of that leg?
3 units.
What's the length for units? Thank you, Pam. What's the length of the horizontal?
7 units.
7 units. So now we can find the length of the hypotenuse by using the Pythagorean theorem. So, y'all find that. Y'all already done it? Yes, sir?
49 plus 30.
Good point. We're going to talk about that in a minute. Using your Pythagorean theorem, find that length or that distance. No, not today.
What?
Not today.
I'm trying to do a squared plus b squared.
I need a volunteer to solve this on the board for me.
Yeah,
Ashley or Tim, they both raise their hands.
okay, who knows where the spin
Ashley or
button is
Tim?
that allows you to.
You got it.
What?
So are y'all listening to me? Okay, epoxy jar, it's come out. What was I gonna say?
Look at Tim.
Look at Tim. Ah!
I'm sorry, I do this.
I appreciate
I
that.
do too, don't worry.
I do this because the kids don't understand what squared and still
And they
it's great.
need to be reinforced.
And they hate it. They're like, you're taking too long. Oh, well.
It doesn't matter in the calculator.
Oh.
Okay, stop right there. So far, everybody understands completely what he has done, correct? You know how to square numbers, you know how to add, all right? So now we don't want to know what c squared is, we want to know what c is. So what is the inverse of squaring something? Ashley D.
Square root?
Taking the square root, and I want you to actually write that symbol in, I knew you were. So we're going to take the square root of each side. Okay, so what is the square root of c squared? C. Those are inverse operations, like addition and subtraction, multiplication and division. They kind of cancel each other. They undo each other. Hang on. What is the square root of 58? She said 7 and, right? So we know it's greater than 7, because 7 squared is 49. We know it's less than 8, because 8 squared is 64. So it's between 7 and 8. Which one is it closer to? He's being very nice to y'all and drawing a line.
That's how you teach it.
I know.
Oh, well, say don't.
Which one is it closer to? 49 or 64?
This number.
Closer to 64.
58 is closer to 64, so the square root is going to be closer to 8 than 7. We still don't know what it is exactly, right? So we're going to leave it in the radical. That's called a radical. We're going to leave it in the radical. So the square root of 58 is the length of the hypotenuse. Yes, ma'am.
And you left it in the radical only because we can't find, without a calculator.
Well, I can, because when I was little, we didn't have calculators, and there were 3 different ways to do it.
Oh, so you just round,
estimate.
get to the closest decimal you could, knowing.
If you have a process to do it without a calculator, yes. Which I can, but
So
y'all
like,
can't.
well, like Tim was drawing, we could have gotten somewhere around 7.7.
You would not want to do it that way.
Okay, so just leave it.
It's not a perfect square, leave it in the radical.
Okay, this is what I was asking.
Yes, ma'am, unless you have a calculator. Yes,
So
ma'am.
is it incorrect or sloppy to say that, because I was taught that if you square root, and I don't know why, I just know this is a fact, that if you have c squared, that if you do the square root, that it gets rid of that square.
Yes.
That's how you cancel it out. So is it wrong to say it cancels it out?
It's sloppy,
Okay.
because these are inverse operations. Remember our mathematical habits of mind? Doing and undoing is one of those.
So it'd be better to say that the square root undoes the square.
Yes, just
Okay.
like subtraction undoes addition.
Okay.
Yes, ma'am.
When would you introduce plus and minus?
Not today. Well, I guess we can, because these are teachers.
Because they'll be positive or negative, the square, because you still end up getting a positive.
My students struggle with that. And they're like, well, earlier we just used the positive.
Yeah, and they do.
So
So,
now we're factoring.
all right.
They go plus or
So
minus.
Ashley actually asked this question, so I'm gonna go ahead and address it. What is the square root of 9, Ashley? Could be 3,
Or could be.
also could be negative 3, because negative 3
Negative
times the
negative.
square is a negative times a negative, which is that positive 9.
I just exploded.
I'll leave at 2:30, so y'all have to focus, all right? See, it's 2. Y'all need to focus, just so we can get through this, and then after I leave, y'all can have all the fun you want, okay?
You
Hang on,
got it typed, it's okay.
hang on. So, I'm gonna put these in parentheses, it's bothering me. Okay, so the square root of this number could be a positive 7 and something, or a negative 7 and something. However, since we're dealing with length, can length be negative? No, so we want the positive answer.
But would you want to teach your students to, okay, the -1 is not my answer because length has to be positive.
Depends
Because-
on what grade level you are.
Right.
Depends on what grade level you are. So, and I just taught that for her quickly because y'all are adults and know this already. If I was in a class, since I'm talking about length, depends on what grade level I'm
Yeah.
in.
Well, because my students are having a hard time being like, well, earlier in the year, we just did the positive, like, we only looked at the positive. And we know, I didn't introduce the plus or minus then, but now we're factoring.
Oh, yeah. I think I would introduce the plus or minus here and then have the discussion about length cannot be negative,
Okay.
just to be consistent throughout the year. Okay? All right. So, what did we get? Square root of 58 is the length of that hypotenuse. And then Brandon asked me if he could use the distance formula, because he is wanting to use the distance formula. So, let's talk about that distance formula. Is it something you have to memorize? Did y'all memorize it?
Y squared minus y1
Did you memorize it is the question.
Yes.
I memorized it. Do we have to memorize it? Where did it come from? Did it just like manna come down? Did it? Came from the Pythagorean theorem. So, you want to do it, Ashley? I'll be happy to. You can? So, we have point J, which is, what are the coordinates?
Negative
Negative 3, 5. And we have point T, which is?
4, 2.
4, 2. Thank you. And we want to find the distance between them. So we want to find the distance between the x's, right? For the horizontal, and between the y's for the vertical leg over there, all right? So we want to find the difference between these two. So we have negative 3 minus 4, right? And we want to square that, okay? These are both x's, so I'm going to, instead of writing the numbers, I'm going to put, and I'll label it up here, x1, y1, x2, y2. So we want to find the difference in the x's, correct? For A. And we want to find the difference in the y's for B. Am I right so far?
Your x's are different
Subscripts.
notations.
On the X.
Use
Subscripts.
subscripts on your X's.
Thank you. I knew I wasn't right. So this is this. This is this. Alright. And we want to find C, the Pythagoras, the hypotenuse. So how do we do that? Take the square root of C squared, which is C, and then we take the square root of all of this. So it's the Pythagorean theorem. So using the distance formula is the same thing as using the Pythagorean theorem. Pythagorean theorem is easier to remember for kiddos. Distance formula looks really weird to kiddos because of all those subscripts. So, and this is an issue with science also, because subscripts in science do not mean the same thing as they do in mathematics. In mathematics, a subscript is like a jersey number. It's just so you can tell this X from this X. You know, the quarterback wears number 15 and the tackle wears number 65. Okay? In science, these mean you have, and I better not say it because I'll probably say it wrong. What do they mean in science? You have one of this kind of atom, and here you have two
Of the same atom.
of this kind of atom. Okay?
You also use subscripts in science when you're working with velocity and speed physics problems.
Similar to
and they're
this,
like that.
as jersey numbers.
Yeah.
Yeah. Which is another thing that confuses them, but it's two science strands that use them differently. So you have to be explicit when you're teaching this. Okay, this does not mean we have two of these. This means this is just different from this. And I use jersey numbers because most kids can relate to that. Alright, so the distance formula is the same as the Pythagorean formula. So could Brandon have used the distance formula? Yes. Do I want him to use the distance formula? No. I want him to use the Pythagorean theorem. Okay? Alright, so, y'all had great questions. So, this is one more example, and then I'm going to let you work some on your own. So we're going to graph these two ordered pairs. Which one is that? That is 2, 0. Rochelle, you got that one right? Yes. And so, which one is this, Pam?
What is this?
I know.
Oh, thank you, Melissa. Which ordered pair does this point represent? Thank you.
6, -6.
6, -6. So we want to find the distance, the length, okay? And I say both of those every time. You want to find the length, the distance, right? And distance is always positive. Length is always positive. So we're going to use the Pythagorean theorem. It says to round to the 10th, but we're not. We're going to leave it in the radical. So y'all go ahead and do that.
Listen, you just like because it's numbers.
It's not abstract, it's a length.
Just let her think it is before you blow her mind. You didn't troll it.
You're not ready.
Good to see you.
One, 2, or 3 more minutes. 0. I'm gonna pull a stick and see what we got. Y'all ready? Okay, Brianna. What did you get?
I haven't got anything yet. No problem.
Okay, you got 30 seconds.
People are working.
Well, then you were focusing on your own.
Oh my god.
But you still have square root of c squared, so just solve the sheet.
Are you telling me I need some?
Well,
I'm ready.
Okay, Brianna has her answer, so
Square root of 52 equals C.
C equals square root of 52, correct? Okay, now she said square root of
I know.
52 equals
I should've
C,
said that.
and I said C equals square root of 52. Does it matter? Not at all. Does not matter at all, because they're equal. You can flip the sides of the equal mark. Okay, good job. So this is their solution. And again, I got this right off the internet if you want to get it for your kids. All right, so we're gonna skip this one, because y'all are so good. And y'all are gonna find these, okay? So we're gonna use the Pythagorean theorem, let me read it to you. To find the distance between the vertices of the quadrilateral that you translated earlier. So you want the distance from A to B, you want the distance from B to C, you want the distance from C to D, and you want the distance from A to D. You do not want the distance from B to D because that would be a diagonal. Okay? So just these four. You have 30 seconds. Be sure that you show all of your work, and you may talk to your partners, of course. Yes, ma'am.
So wouldn't this probably be more appropriate for the distance?
It's one thing or so.
It's 3 o'clock, my brain's shutting down. It's not
Not enough caffeine.
it's not registering right now.
Counting the quadrilaterals. CD is the line, so we put in the right triangle, so that's a 3 by 2. So this is 3 squared plus 2 squared. Since AD we can't create a right triangle without you count the length. So 1, 2, 3, 4, 5 units. So that's 5 is 8 units.
That's why it wasn't registering. I'm like, what?
Yeah, but 2, since we can't create that right triangle.
A to C. What's 2 squared? What would it be?
It's not fair, you did not move it all out.
So everything is just straight toward
This line's just like drawing
It's a 1 by 3.
one line. This one line. So you could create a
No, because it would be like.
So from A to B, again, one leg is one, the other leg is
Call that maybe.
1, 2, 3.
Please talk to your partners, make sure you're all working these correctly, make sure you're not using a calculator.
Yeah, it would be draw a right triangle first. You can create that right triangle, and so is your right triangle. Yeah, that's perfect. So what's the dimensions of the triangle?
Right, if we did.
That's because I know it all. Well, there's no change.
Okay, yeah.
If I bring mine,
My son,
From negative 2 subtract that username that has from us. This is right.
is there something I would be in
I'll be here
One way, actually, you see the video, so G equals somewhere where every line is oh, duh, totally over here.
Yeah, you're, once at this point, you go back to like a normal part. You're like, it's right.
It's right. What if I were,
Just use the distance formula, then yes.
But it was still all the way cool.
It'll become, it'll become
Anyways.
I can hear the.
I'm trying to think what it is.
Not that.
It would have been 4 plus 0, yeah, square root of 4, so it would have been 2. That's what would happen. It would have been 4 plus 0.
X is a change in 2. And there's no change in the line.
Oh, no, I mean, because 2 squared makes it 4.
Oh, duh.
So square root of 4.
So we just have to only thing is, what's the distance of your seat? Right there. 2. We did this because, we don't know the, order. Right, how much of a unit? Okay.
What about D?